All right, so let's go ahead and take a look at today's warm up. So for question number one, it says the cost of 2 pounds of potatoes is $3.78. What is the constant of proportionality that represents the relationship between cost y to the pounds of potatoes x? Now, the great thing about this is, like I told you, everything in math is always alphabetical order besides proportionality, direct variation, slope, rate of change. Even though all of those are the same thing, of course, people use different words for them. But we know that this one is backwards. So it's going to look like this. It's going to be k equals y over x. And now all I have to do is go ahead and plug in my x as well as my y. And I can reduce it. I'm going to go ahead and use my calculator here. 3.78 over 2, 1.89. Now this is significant because this tells me $1.89 for every pound of potatoes. This is how we would do it in real life. We would talk about how much each pound costs. Okay, number two. Rebecca's piano lessons cost $45 per month. Complete the table below to show the cost over the next 8 months. So that means every month I have to pay an additional $45. And this column here is my total cost. Total cost. So what they're asking me to do is first month, $45. Second month, I add another 45. And I keep doing the same exact thing. And I end up finding how much was the total amount of money that they've paid out each month, including the previous month's money. So let's go ahead and get on to our lesson. Here, our lesson is going to be located on page 16. All right. So, yesterday we talked about combining like terms, which things we can put together and which things we can't. Just as a summary of that, we can put together stuff that is exactly the same. So x's can go with other x's. XY's can go with other XY's. But A's cannot go with B's. Now, this is a really important foundation for solving these one-step equations. Okay? So, anytime we're dealing with an equation, of course, we're going to have to combine like terms. We might have to do a couple of different operations. There's a lot of different things that we can do. But today we're going to be focusing on what's called inverse operations. Subtraction, multiplication, division, and, oh, put subtraction in the wrong box. Addition. So in order to solve an equation, we must isolate the variable and keep each side of the equation balanced. We can use inverse operations to move terms from one side of the equation to the other. Inverse operations can be thought of as opposites or undoing operations. So all that sounds fine and dandy, but in real life, what they're telling us to do is we just do the opposite of something in order to move it away or get rid of it. So let's take a look at a couple of examples. So you guys are going to be working on page 16, page 17, and page 18. That's going to be your assignment for today. I'm going to do a couple of random problems throughout, okay? So let's take a look at the very first one. 4x equals positive 16. Well, remember what I told you guys last time. If you're trying to solve an equation, the x can be thought about as a mean old man. He likes to be left alone. He doesn't want to be bothered by anybody. I see over here on this same side of the equation there's a 4. So the x is really upset. He wants to get rid of this 4. I look in between the 4 and the x, and I don't see a plus, minus, or division. Therefore, they must be multiplied. And if I know my operations, the opposite of multiplication is division. So I will go ahead and I will divide both sides by 4. And I end up with my x isolated or by itself. And I also get my answer, x equals 4. So it doesn't matter what I see over here. I just do the opposite of it. So let's take a look at number 2. X plus 9 equals 13. Again, my x is mad because he wants to get rid of that 9. How can I get rid of it? I see that it's adding, so I'm going to do the opposite, subtracting. I'm going to take away 9. And I have the exact same answer. Very interesting. All right. So now let's keep going. Here's a good one. X divided by 5 equals 13. I want to get my x by itself. 5 is currently dividing x, so I'm going to multiply both sides by 5. I'm doing the opposite. And I end up with my answer. Now, there's a very special problem. Where is it at? Here we go. There's a very special problem. Now, this is something that you probably will not learn until you head to high school. But I'm going to explain it to you now, and you're going to feel like a super genius whenever you remember this. So here it says 2/3 x equals 8. Now, fractions are interesting because technically this top number, my numerator, is multiplying, and this bottom number is dividing. So what does that mean? Well, that tells me that I'm going to have to do 2 steps. This is not just 1 step. That's okay, though. I can do this in 2 separate steps. Let's get rid of that the 3 first. So I'll multiply both sides by 3. They'll cancel here. Now I'll go ahead and I'll get rid of my 2. So yeah, I could totally do it in 2 steps. Super easy. However, let me just go back for a split second. Whenever I have a fraction like this and I'm trying to get rid of it, I can multiply it by something called its reciprocal. I think I spelled that right. Let's hope. Reciprocal. A reciprocal is just a fraction flipped upside down. So I take whatever's on the bottom, write it at the top, and whatever's at the top, write it at the bottom. And I do it on both sides. The magic in this, cancel, cancel, and my x is solved for. Now all I have to do is do this operation over here. And I can do this in any order that I want to. I can say 8 times 3, then divide by 2, or I could do 8 divided by 2, then multiply by 3. So I'll do the second one. 8 divided by 2 is 4, times 3 is 12. And we get the same exact answer. All right, let's take a look at, let's see here. Oh, here's a good one. Number 6 on page 18. So here I have negative numbers. Again, my ex is a mean old man. He doesn't want that negative 8 over there. He's like, you need to go ahead and head out of here. I don't want you here. So I see that my negative 8 is multiplying. So I need to divide. But I can't just divide by negative 8 because then I'll end up with negative x over here. I've got to take that negative with it. So remember, anytime you start seeing negatives or minuses, always be very careful with them. So whenever I divide by this entire coefficient that's in front of my x. And I'll end up with a positive answer because two negatives make a positive. Okay, so let me go ahead and do 2 of these word problems and I will send you guys on your way. So if a chocolate cake is divided into 6 equal slices, each slice has 280 calories, how many calories are in the whole cake? Okay, so we talked about dimensional analysis, which is way above this, right? But the same rules apply. They told me 280 calories per slice. And I want to change into an entire cake. So now, oh, whoops. I want to change this into calories per cake. So I need to get rid of slices. How many slices were in one cake? I see 6. 6 slices. Slices cancel, and I can multiply these out. 280 times 6. 1,680. So notice, I'm using the wording they gave us. Each slice has 280 calories, 280 calories per slice, multiplied by 6 equal slices that the cake was divided into, 6 slices per cake. And if I multiply these together and I look at my units, I can cancel off slices. And I'm left with calories per cake, total calories for the cake. All right, one more. All right, so here we go. Make sure that is the correct problem. Yes, okay. So, Samuel is 6 inches taller than his brother Elijah. So, if Samuel is 48 inches tall, how tall is Elijah? So, my variable is Elijah's height. But I'm going to show you what we talked about before, which I call translating. So, Samuel is, when I see the word than, I do things backwards. 6 inches taller than Elijah. Samuel is 6 inches taller than, let me do that in a different color, Elijah. So I have an equation. S plus E equals E plus 6. And they told me Samuel is 48 inches. So 48 equals E plus 6. Now I need to decide how in the world am I going to get E by himself. E is a mean old man alone as well. He wants to be by himself. So I need to get rid of that 6. I see that my 6 is adding, so I should go ahead and subtract. And I end up finding out that Elijah is 42 inches tall. All right, so I want you guys to go ahead and focus on finishing up the problems that are on page 16, 17, 18. If you did not finish your posters from last time, please feel free to go ahead and work on that today as well. And I'll see you guys tomorrow.